Looking at the unit circle, I'm going to go over a couple of hints here for this lesson. First of all, we need to remember that we have the x and y axes, meaning that we have the coordinate point 0, 0 right here. And with that, we should be able to come up with our coordinate points for 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Because we have a radius of 1, so we should be able to figure those out. Those are x and y intercepts of that circle. After that, taking a look at 0 degrees right here and 180 degrees on this side, the whole circle is 360 degrees all the way around, so 0 is the same as 360. Also, from looking at radians, we are starting here, and it is 2 pi radians all the way around the circle. Therefore, if 180 degrees is halfway, that is going to be 1 pi. So going halfway around that circle is 1 pi radian. From there, we can start figuring out several others. I am going to skip the 15-degree angle because we do not have exact coordinates for the 15-degree angle. And I'm going to go straight to the 30-degree angle right here. So that is 30 degrees. 30 goes into 180. 6 times. So that means if I'm thinking of radians, if this is 1/6 of that, in radians it is also 1/6. So pi is the whole thing, and divided by 6 is the radian measure. So if I know that that's pi over 6 radians, I can also then figure out this one here. Now, we had previously learned that for degrees, I would do 180 minus 30. So this is 150 degrees. I can do the same idea right now with radians. So I know that it is 1 pi all the way over here. But I need to subtract pi over 6. Now, I do not have a common denominator, so I want to make this 1 pi right here into 6 pi over 6. I now have a common denominator. 6 pi over 6 is 1 pi, because that's my giant 1. So now, when I have that, I'm going to subtract those, and I'm going to get the answer of 5 pi over 6. So that tells me that 150 degrees is now the same thing as 5 pi over 6 radians. Using the same thinking and the same logic, I should be able to get this one here. In degrees, that would be 180 plus 30. So that is a 210-degree angle. So if I'm going to do the same idea now in radians, I'm going to do pi, which is there, plus a pi over 6. Again, getting a common denominator, I have 6 pi over 6. So that means that 210 degrees is equivalent to 7 pi over 6. Getting the fourth quadrant, I would be doing 360 minus 30, so I would get 330 degrees. But now, 360 is equivalent to 2 pi. So now I would take 2 pi minus pi over 6. So now when I make this into a common denominator, I don't get 6 pi over 6, I actually get 12 pi over 6. So once I have that, I subtract those, and my answer here is 11 pi over 6. The next thing I want to think about with these is if I have this triangle right here with 30 degrees there, I can now figure out which one is my short leg and which one my long leg. So short leg is opposite the 30, long leg is opposite the 60, and I can then write my coordinate point. Once I know that coordinate point, I should be able to get the coordinate point here, here, and here. Because the values should remain the same, I just need to know whether they're positive or negative. Once I have all of those triangles, then what I'm going to do is I'm going to look at the next one, which is now a 45-degree angle. So 45 degrees, I can then figure out 45 goes into 180 how many times, and then I can use that to figure out how many radians it is, since that's pi right there. How many radians am I going to have right here? After I get that, I can figure out that triangle, and that triangle, get the degrees and radians, and then once I have this triangle here, I can get my side lengths and get my coordinate points. I will continue that for the 60-degree and getting these other points here, and those are my exact coordinates around the unit circle.